Today we look at presenting the data in tables and graphs. The important thing is to present your data clearly and reasonably simply. So you people are going to get a spreadsheet with a whole lot of data on it. Your first job will be to select just the data that is relevant to your investigation that will assist you in addressing your hypothesis. Last year's data looked like this. It's a big table, so I'll show you bits of it at a time, in which you've got the various independent variables that people had. I'm expecting that the final set of data that you get will be something similar. Note that everyone will be using the control data and then as many of the trials as is relevant to your investigation. So if you do something about alcohols, this data has got 4 alcohols you could use. Well, obviously the control data is ethanol, so you'll use that. Then you would use methanol, propanol, and one or both of the 2 butanols as needed. If your investigation was to do with changing the amount of water, then clearly we've got the control data with 100 mils. Then we've also got 150 mils and 200 mils as well that you can use. The height distance between the burner and the beaker, various things like that. I'm not sure exactly how many things we'll get, but your job is just simply to choose the ones that are applicable to you. Then the rest of the table looks more like this, in which you've got 3 replicates for each condition. So the control, there's 3 sets of control data, so the first replicate, second and the third. So over here we've got the mass of the spirit burner, so as the alcohol burned, obviously the mass went down. And we've got the temperature of the water here as well, so started off low, got higher. And as well, we've also got the mass of the water that was heated was recorded. So the control data, don't know what happened here, it went up to 110 grams. You'll see for the 150 mils of water, it's just a little bit below 150 grams. And the next row down, which is the 200 mils, looks like it was a little bit under 200 grams. Can't quite see that bit of the table. So you select your data and present your data in a neat table. Now you'll see that I've listed the 3 replicates in 3 separate rows there just to make it a little bit clearer. Of course, I've calculated the change in mass of the spirit burner, that is the mass of fuel that got burnt. I've also calculated the change in temperature in my data here. And of course, I'm still including the water mass because that will be important in the calculations. Note how I'm careful and diligent in my formatting of the table. I've got clear titles indicating what each row and column represents. And in the title to a column, I've always got the units indicated. That means I don't have to include the units in every single value in the table. Units are important. Next we do the calculations. So first of all we calculate the energy and then the heat of combustion. So the energy, I've decided to convert it, calculate it straight as kilojoules here, for clarity. And then divide by the mass of fuel burnt to get the heat of combustion. Fairly routine Unit 3 calculations there. Now, they're the calculations everyone will do. You'll do the calculations in your logbook and just include the final results that you calculate in your results table. Then your investigation may suggest that you calculate other things like percentage heat loss or the percentage of the theoretical heat of combustion, etc. That's up to your particular investigation. So then you'll include them in your table as I have here. That's the complete table that I would present. Now, once you've got those, it may indeed be worthwhile to calculate averages. Now, I've got heats of combustion which can clearly be averaged, and my investigation here was changing the mass of fuel burnt and seeing whether that would give me a more accurate heat of combustion, the more mass that I burnt. And so since we've got fairly consistent masses of fuel burnt at each of the levels, I will calculate the average mass and the average heat of combustion for each one of the conditions and present them in a nice simple table which pretty much summarises the investigation that I did. Then once we've got that, we can produce a graph which will visually really clearly show what's happened. Now, in this case, I've got a numerical independent variable. That means a scatter plot's probably ideal. I'm going to use the average data, and I'm not going to include a line of best fit because I think the trend is fairly clear and a line of best fit won't actually add a huge amount. I could have used a histogram. And certainly if you've got a discrete numerical variable, a histogram is probably the preferred way of doing it. That is, if it's just something that counts up in numbers like the number of carbons being 1, 2 and 3, that's where a histogram would be good. But I've done a scatter plot here. Being careful with my formatting, so I've got the mass of ethanol burnt and on my x-axis and the heat of combustion on the y-axis. Clear labels, units, all that sort of thing, a title to the graph. And it's clear what's happened. For some reason in my investigation, as the mass of ethanol burnt, the heat of combustion became less and less accurate. It's a lower and lower value. Something went wrong there. But that's for another day. As I say, if you've got a categorical independent variable, then it's going to be a bar chart that you have to use. So something where we're not measuring the independent variable with some numbers, but they're in different categories. And so present the tables and the graph on your poster. Everything else goes in your logbook.